Hello everyone, this is Franck Contrepoix. Today I'm going to do a demo of a forecasting tool that I've built using the approach that I follow, which is named Context is Everything, and that is the mantra that underpins my company and what I do every day. From the software perspective, what that means is that we follow a unique philosophy. Every piece of software do one thing well. We try to compose things with using pipes or equivalent tools. Everything is text-based, fails fast. It needs to be independent. Every piece needs to be independent. No import between comments. They just work. You don't need the other tools if you want. They can work together, but you don't need them. Every command is self-contained. And we use just Python standard library as much as we can. All commands follow the same input-output patterns, structured data, CSV as a standard way, but we could use something else. Error handling is consistent and documentation is well done, and that's also thanks to AI. So let's start with the context, which, as you understand, is important for me. In this case, we have that little box in the middle. That's the forecasting tool. And what it does, it takes a CSV, which has a date and a number, and gives you back another CSV, which has date, the same number, but then also one column for each algorithm that is implemented. It's reasonably easy to add new algorithm or to remove some of them or to select just the one you need. Yet what I want to test the algorithm. I want to see if my implementation works. I want to see through graphs because it's extremely hard to see anything just by looking at the numbers. You don't know if they make sense, how they stack to each other. And I want to make a video, which is what you're seeing now, because I want to share what I've done. So the concept, what is missing? What is missing is data. So I don't have really data. I want data that, flat, growing with spikes growing. I want you as a person to be able to reproduce that data or those experiments that I'm doing, that demo. And I want it to look cool and have a graph, as I said. So just part of the thing is, as this is my context, I want to do a demo, I had to generate some new files. So I generated new tools. So generate a generate series tool that generates series. I've created a spike, add spikes to any series of data. It's going to add spikes. That's another specific tool. And then the last one is I used a tool that is called Observable Framework to try to model everything together and make it all work. So let's go into the demo. What we'll try to do is we'll create data, which is a flat baseline, some growth, some flattened growth with spikes. I think more than 10 and 20 I went to, or even 33%, and more just to stress test the models. The idea is that the system delivers you all those algorithms, we'll use all these algorithms, we'll generate them, and it takes less than 5-10 seconds with daily data. So there is the simple moving average, very stable, low to react. There is a weighted average that favors recent data, the Holtz winter, the ARIMA, the SARIMA, the theta, the profit, the neural profit, and ensemble, which is the average of all of those models. The interesting bit is big chunk of these, I have no clue what they do, which is why I want to have an understanding of what they're doing, not only reading here, but also seeing them on graphs. So in my model, I have to create a first thing, which is I need to activate an environment. This is a Python specific thing. I need to install all the requirements, no surprise there. And I'm going to create two folders, demo input, demo out. This is to make it clear separation of where do I get my input, where do I get my output. So let's start by creating flat, no noise, 1 year of daily data. And this is done, as I said, with a tool that is called Generate Series. And Generate Series patterns flat, granularity is daily, the period is 365 days, the baseline is 10, so it's going to show me numbers 10 all over the place, there is no noise, and the output is going to be that file. And so it's going to create something, that file, and you can see the graph at the side, and that graph shows you everything's 10 for 1 year. So now I'm going to run the forecasting. And so the forecasting is run like this. So Python forecast.py, then input. What is the input? What is the date column? That is the value column, because might be, in this case, it's cost, but might be anything else. I want the ensemble, and this is where you're going to put it out. And so we can see at one point that the forecasted data is all tens, which at the moment tells us that all the models know how to forecast something that is totally flat, which is reassuring. So now we're going to start something which is growing a little every day. So we're going to run this command, which is upward trend. We're just going to say the trend is 0.5. And so that's going to make it quite simple. You can see it there, 10, 10.5, 11, etc., etc. And that's a linear graph that you can see. All fine. Now we run the forecasting on this and we get data, and you can start seeing that they are slightly different. And then we're going to want to look at that and, ooh, nice. So we start seeing differences. And if we go onto here, we can see that some algorithms just stop. They do their calculation once and that's it. Some others, like Ensemble, shows you the growth. Some are overachieving there, the HW. Some are quite theta, seem okay. But most of them follow the trend, so that's cool. So now let's do is flag, but with some spikes. We can up to daily. So if you look at the command, we're going to generate a flat like before, but now we have add spikes. And add spike is going to take that input file. The output is going to be the same. And it's going to have maximum 10% of growth. And there is a 5% chance that they are going to happen every day. In this case, day, yes. So we're going to look at that, and it's going to do this. So this might be different if you run it. You might have different percentage or different spikes time, but overall, that should statistically be correct. And so we, again, run our forecast system. We get tons of answers. So in this case, if I go down, I can see the spikes sometimes, and I go, here we go, and they start all showing me different things. And yeah, spikes are small, and you can see that that doesn't really change much. The only one that seems to slightly struggle is the HW. Not struggle, but goes down while everything was flat and only going up. So that's interesting. So let's do flat with spikes, but this time we're going to make 5% chance, but they can go up to 40% of the spend, okay? So they can go big. So this is the kind of stuff we're talking about. We run the forecast as usual, and we get something like this. So overall, every model is doing reasonably well still there. Every time it's flat, they remove the noise that are these spikes, and still quite a lot of noise, but they are getting good. Now let's move. I'm going to have flat with spikes, but it can go to 33%. So again, we're going to do all our stuff. Like before, nothing big changed. I just wanted to check if there was really difference between two tries. No. Now we're going to go with growth. So we're going to have spikes and growth. So upward trend, daily, we want the trend is 0.5 like we've done before, but then on top of that, there is a 15% chance that we're going to have a spike up to 33% of the spend. So that shows me something like this. That is way more messy. Okay, and the result is way more messy. So for these kind of things, you probably want to be with the purple there, which is the Sarima, or you want to be with Prophet. This is the ensemble, which is an average of everything. Theta seems to be lost, at least at the beginning. It starts with completely different values, which I don't completely understand. So each of these ones have parameters, which I have partially implemented because I don't really understand them. But yeah, that's overall. But have a look. And while in this case, I've used the day of today to separate the things, nothing is blocking you for taking dates. But for example, let's say that I'm going to create until January because I know that in December we have Christmas, and I might just take the past information, add some. you can do tons of things. The tool is extremely flexible for you to play with and create forecasts that you can justify, you can defend, and eventually many of them and experiment with. Thank you.